Hello everybody, today we're going to continue our Flippy Bird game in OpenGL and OpenGL tutorial in base. As you remember, we are using SDL and OpenGL. I'm sorry for not being on internet for a month, so let's get started. Let's open our file. We will write all the code in one file as a beginner. So, first thing I want to mention is a mistake I've done on a previous video. I accidentally put glue in it before gel context. You just need to drag it here. Yeah, and yeah, that's basically it. Because glue will initialize itself for gel context that exists, not before it exists. You got the point. Now, so what we gonna do now? We let's run our main. Yeah. Oh, I forgot. So I made a script for build, but let's make it from 0. Now let's run it. So we have our window. Yeah. It's right now 800 to 800 here, and we can we have to say that it has no coordination system, normal coordination system. It has a 0, which is the center of our window, and a 1, which is the end of our window. And here is a +1 for y coordination and +1 for x, and same -x and -y. And we are basically gonna draw our first triangle without shaders right now. That will be 1, 1, 1. It has 3 vertices that OpenGL will draw between, and we just need to give its coordinations. And as OpenGL works on GPU, we need to load that info or that data into GPU. That's all we are gonna do today. So let me close it. And first thing I'm gonna do is to write down our data that we're gonna use. We always use a float for a data of coordinates, as OpenGL always wastes float. It will be, I will call triangle, that will be array, because it will contain all the info of points inside one array. So we have 3 points. As we are making a 2D, we will have only 2 data about our vertices, the x and y. And let's start with x. So we have first the vertex that we're gonna give. It will be here, which is by x 0 and by y 1. So I will write 1, basically 0 for x and 1 for y. Let me do it like this, just for clarification. And now the second will be here. It doesn't matter how you're gonna put it here. You can start from here. It doesn't matter, because OpenGL will figure it out itself. So second will be if it's here 0, here will be -x and -1. So -1 and -1. Now the last thing, it must be here, plus x and -y, right? So 1 or +1 if you want, and -1. Now that should be correct. And let me close it because we no longer need it. So now we have a info of coordinations. Now what we're gonna do is to load it into our GPU. In order to load it, we will need to create it on CPU first. That only stores triangle as a and makes it ready for a GPU in a simple sense. It's also for this we use integer for the data that will be stored. an unsigned integer, and graphic library OpenGL has its own data type that is called GL unsigned integer or GLUINT. GLUINT is just an unsigned integer. Graphic library unsigned integer. And now we call it VBO, vertex buffer data. That it's just a buffer for vertex object or this vertexes. Now after creating it, we create it on GPU2. For this we write glgen generate glgen buffers, and here we give a size. I want to create one buffer, and what we're gonna use is VBO for there. For the buffer, that will be VBO. Now we need to attach it gl bind buffer, and by binding I mean we will have array buffer gl buffer array no elementary or array element. Let me see. Yeah, array buffer and VBO. Now after writing it, let me explain it. We create a VBO on CPU and create an open based on VBO buffer on one buffer, one buffer based on VBO on GPU. Then we attach our VBO in CPU to the GL array buffer, which is an array that will be read on GPU, that stores VBO on GPU. Now we, by using GL buffer data, load to the GL array buffer or a triangle and data, so it will be on VBO2. By this OpenGL reads it, so or just stores it right now. It will read it later. So what we're gonna do is GL array, so it will kind of load triangle. So first it must know how much size it will have, or how much size or future loading must be. So I would just say it's size of triangle. Yeah, so size of triangle, and after that we give the triangle itself, oh god, triangle, and now we must declare what it will be for, what it must use it for, and we just say static draw. It just draws it. Now as we loaded our triangle on GPU by this, we said that we gonna load triangle to GL array buffer, which is connected to VBO, so the last VBO, so it will load or this to array buffer, which contains the last VBO, and loads it to VBO itself, that will be read by GPU, and it declares the size, pre-size, and then loads triangle and declares as a static drawing element data. Now we must say how GPU must read it. GPU reads it by okay, that's the second thing. For this we must load it to a special thing, enable vertex array attribute. No, not this. GL enable. What was that called? Here it is. So what it is, GL enable vertex attribution array is an array of attributes for an object that will be drawn. This 0 is just used for a vertex transform, vertex coordinates, and first will be used as for colors, textures, and search for normal maps and so on. So it's just the layers that declare what stores what and how it must be read. So our GPU will load first the coordinations, then the texture, then the normal maps, then diffusions and shadows, and blah blah blah, so on. So for now we just need to mean that our coordinations, this all will go to 0 1, basically 0 attribute array. And now we must say how and attribute array will be rated by GPU to load this all onto screen. Now we must tell it how our GPU will read all this. To this, for now, we will use GL vertex attributes. Yeah. By this, we tell OpenGL how to read it. Let me find it. Attribute pointer. Yeah. Now, by this we tell how OpenGL must read it. First, we tell what OpenGL must read as the way it is. It's a 0 attribute array, and the size of it, which means per vertex we give a size that will be read. Like for currently we use 2D, so we have a 2 data for per vertex. So we must say it must be 2. It will be 2. And now the type of our is float, so we will write GL float, so basic nm number, and gboolean normalized. We don't want our coordinates to be normalized, so we say false. And now GL size and pointer. These things are not much important for us, as because we wait a minute. Oh yeah, we must say GL false. Yeah. And for this two is not that important. This two are for when you wanna save in our triangle vertex more than just the coordinations like colors and normal maps, but we will not use it, at least for now. So you don't really have to care about this two for now. So now, as we did it, we must draw our triangle. Here I wrote this, and let me delete it. So as we remember, we have here our SDL pool event and key state event. Now here our clear color and swap window, and between this two we write all render stuff. For now we write like this. GL draw triangle, or no, GL draw array. Yeah. So here, this is how we draw our thing. So we loaded it, we told how to read it, and now we just need to render it. So here we say it will use triangle, so when it finds three continued vertices, it will just combine them into one triangle. For that we say triangles, GL triangles, so it will just find three vertices and combine them into one triangle. And the size of it, it means where it should begin from 0, and the count is how much vertices it wants to draw. For now only 3. Now let's compile and let's try to run it. Here we have our triangle. I recommend play with coordinations, like I love to make it half size. You can do the same for yourself and experiment with it. Like try to rotate it if you understand matrices very good. So let's run it. Oh, I accidentally did it like this. Doesn't matter. At least it's nice. Ah, yeah, I accidentally put it here. Yeah, that's oh, let's try to make it a cube. How you think about it? So we just copy this. Oh, oh God. God. Okay, so it happily ignored it. So it just, let's do like this. Now let me put semicolon here. And now it has two triangles that overlap each other. In order it to not overlap each other, we just put some minuses and all of that. So let's firstly run our program to understand where it should be. So first one is here. So second one be on opposite side. If it is the how to read 1 2 3 1 2 3, right? 1 2 3, and from here we will start our second triangle's vertex. You can start from here or from here if you want, doesn't matter. I will start from here. Here is the same as the first, 5 5, so it doesn't problem. And here the second will be here, same, minus minus, and the third must not be here, but rather here, which is if it is here is our center, then it must be minus by x and plus by y. So here I just minus x and minus 5. Let's check it. Oh, so something's trying to not worked, I guess. I know, it's a problem. I forgot. Said when we draw, we said we will draw only three vertices. We just need to put it as 6 here. So now it should work. Oh yes, here our cube, a perfect cube, a white. And thank you for watching, and also I think I have. Okay, now let's make a build script. I have already write this for a bash script, and it's quite nice to use it. I recommend you to do the same. I usually do it for my most projects. Try it. So let's recheck what we did. We fixed our problem in last video by putting init after gel context, wrote triangle coordinations on a float array, created VBO, buzz on CPU and GPU, binded it on a gel array buffer, and gave how it must be read by our GPU, and rendered it and created a firstly triangle, then a cube. Thank you for watching. If you find this video useful, I will be happy. Just let me know, and peace.